So we want to maximize the amount of light that's going to come through this window. So in other words, we want to maximize the area. So we need a formula for area. So let's give this thing some variables. I'm going to call the radius of that circle r, and that'll make the bottom twice that. And then the height, I don't know what that is, so I'm just going to call it h. So the area of that window is the rectangle plus half a circle, and the area of the rectangle is 2r times h, so 2r times h for the rectangle, and then half a circle is plus half pi r squared. If I want to maximize this thing, I really only want to talk about it in one variable. Right now I've got r's and h's running around, and that's not good for me. So fortunately we know something about our perimeter. It just equals p, which is just not too exciting, but it's a constant, so we'll work with it. So if I talk about the perimeter of this, I'm going to have, if I start here and walk around, I have h plus 2r plus another h plus half the circumference of a circle. So we've got 2 h's plus 2r plus half the circumference. So 2 h's plus 2 r's plus half the circumference of a circle, which is given by 2 pi r, and that equals some number p. So if I solve this for h and plug that into there, that's going to be good. So I'm going to solve for h. 2h is going to be, just toss everything else on the other side. So there's a p already over there. I'm going to subtract over a 2r, and the 1/2 and the 2 will cancel, so I'll just subtract over a pi r. And so then h is just this whole thing divided by 2. And I'm going to substitute this in for that. So I'm going to have 2 times r times p minus 2r minus pi r all over 2 plus 1/2 pi r squared. Now the 2's immediately canceled, and I probably could have seen that earlier, but they cancel now. So the 2's are going to cancel, and then I'm going to distribute the r. So I'm going to have p r minus 2r squared minus pi r squared plus half pi r squared. So yay, it's only got r's, which is good. The p we're not worried about because the p is a constant. So we're not worried about that. But now we have to maximize this equation. And every time they ask us to maximize something, if we don't know calculus, we're expecting it to be either a linear programming problem or maybe a parabola. Because if this is an upside down parabola, then its maximum is going to happen at the vertex. And that's what this is. The biggest power is an r squared, and so the maximum is going to happen. It's a parabola with a max at the vertex. So I need to write this in kind of a standard form, ax squared plus bx plus c, and then I can find the vertex by doing x equals negative b over 2a. So if I gather my x squared terms and my x terms and my constant terms, I have no constant terms, just this x term. Here we have r's instead of x's, no big. And then if I pull out all the r squareds, I see my coefficient here. I have minus 2 minus pi plus 1/2 pi r squared. So this little guy here, that's my b, and this whole mess there, that's my a. So we'll use x equals negative b over 2a, and here we have r's instead of x's, so r equals negative b over 2a. So I have negative p over 2a, which is that mess, so negative 2 minus pi plus 1/2 pi, and this will equal negative p over negative 4 minus 2 pi plus pi, which will equal equal negative p over negative 4 minus pi. There's a lot of negatives in there, so if I just multiply the top and bottom by negative 1, that'll swap all the signs for me, so it'll be p over 4 plus pi. And that's my radius. That's the radius of the circle that's going to maximize that area. Wonderful. They ask for all the dimensions, so to be on the safe side, we're going to give them the height as well. The height is just based on the radius. We just have to plug it in, and we'll tell them that too. So the height is going to be p minus 2 times the radius, which was p over 4 plus pi, minus pi times, plug in the radius again, p over 4 plus pi. So, and all, of course, over 2. So if I get a common denominator for the top, that'll be pi plus 4. So I'll multiply p by 4 plus pi. And these guys already have the denominator, so that'll just be minus 2p minus pi p all over the common denominator, 4 plus pi. And that's all over 2. If it's all over 2, that's like multiplying by a half, so I'll just write it out there for now. Just keep cleaning the thing, distributing the p. I have 4p plus pi p minus 2p minus pi p all over, I'm just going to say 2 times 4 plus pi on the bottom. Now I've got 4p minus 2p, no, 4p, that's it, because the pi p minus that goes away. Where did I lose it? 4p pi p. Lots of pi's and p's. Ah, oops, just miscopied right there. That should be a 2p. So 4p minus 2p is 2p. Those pi p minus pi p go away. All over 2 times 4 plus pi. The 2's cancel out. So the height is the same. The height is also p over 4 plus pi. So the radius is that, the height is that. That'll maximize the area. Ta-da!